composite functions. Today we will be learning about functions. Now in maths, a function is an operation or series of operation that transforms a set of numbers into a different set. So for example, let's have a look at something like f of x equals 3x plus 8. Okay, that's our function. So this means, for example, you could have something like this. Input means that you are going to, whatever your x is, you are going to times that by 3x. And then what you are going to do to it is you are going to add 8, and then you are going to be left with an output. Okay, so that's a function in maths. Okay, now you might be thinking, well, actually, what does f of x mean? Well, f of x in maths is the mathematical notation for the function, for this function here. So basically f of x means that you are going to be timesing by 3, then you are going to be adding 3, okay, at the end. Right, okay, so if you have something else, let's have a look at another example of something like this. You might have f of x equals 4 times x plus 5 minus 1 all over 2. So slightly more complicated than the first one, isn't it? So again, that means that you will have an input, so x will be something. You are going, now remember, you have to look at the rules for BIDMAS or BODMAS as somebody calls it. You do the brackets first, don't you? So whatever x is, you're going to have to add 5 first. You're going to add 5 first, then you are going to multiply by 4, okay? Then you are going to subtract 1, and then you are going to divide by 2, and you will end up with your output, okay? Now, things are slightly more complicated at GCSE level, where you have to substitute or work out the inverse of certain functions. So let's look at some examples of things that you will be asked to do in your GCSE exams. Okay, so I'm just going to write examples. Okay, so these are the type of questions that you will be asked in your GCSE exams. So number 1. Okay, so for example, let's say you've got the function of x, which is 3x. We'll start off nice and easy and simple to start off with. Your question might say, calculate f4. Now, you can see here that your function is f of x, which is 3x. Now, that means obviously you're going to times your x by 3. Now, you can see here clearly that my x here is in brackets, but the x has been replaced with 4. That means x equals 4. So all I do is replace my x with 4. So 3x means 3 times x, isn't it? So 3 times 4, which is 12. So your answer is 12. Okay. Another example like that. So let's have a look. F of x equals 4x plus 2 this time. And we are going to say calculate f3. Okay, so again, you can see here that the x has been replaced by 3, hasn't it? Yeah, the x has been replaced by 3. So you are going to do 4 times 3 add 2. Well, 4 times 3 is 12. 12 add 2 is 14. Okay, it's just a slightly different way and a more complicated way of saying substitute numbers in. Okay, let's have a look at just a few more examples of something like this, and we'll move on. You might have something that says f of x equals 3x squared plus 1, calculate f, 2 this time. Okay, so again, the x has been replaced with the number 2, so that means x is 2. So you're going to replace x with 2. So you're going to do 3 times 2 squared add 1. Well, 3 times, 2 squared is 4, add 1. 3 times 4 is 12. 12 add 1 is 13. Okay. Right, okay, so that's pretty simple and straightforward, isn't it? Now, things can get trickier from here, and I'll show you why and how. Okay, so that's just simple questions that you might be asked to answer in your exams. They're only worth 1 or 2 marks. This gets more complicated, so let's have a look at more complicated examples. So I've got f of x equals x squared and g of x equals x plus 1. Right, the first thing we are going to do is we are going to work out fg of 1. Right, this is the most tricky bit because you are used to seeing above just f of x equals, f of x equals, f of x equals. But now we have got two functions. We've got one function that says when you know what x is, you are going to do x squared. And we've got another function which is g. And when you know what x is in that function, you've got to add 1 to it. So this is how you answer these type of questions. You take this one first. So we're looking at we're looking at g of 1. So we're going to take the function of g. So g of x is x plus 1. And remember, it's g1. That means in the function of g, x is 1. X is 1. So we're going to do 1 add 1, which is 2. Right. I now know this bit here is 2. So what I'm going to do is I'm going to write f of 2 now, because in the function of g, when I replace x with 1, my answer is actually 2. So now in the function of f, I need to substitute x as 2. So that's x squared. So it's going to be 2 squared, which is 4. Okay. So slightly tricky and slightly more complicated this time. Let's have a look again at another example like that. Okay. Let's zoom in a little bit. Right, so let's have a look at fg of 3. So again, we've got g of 3 first. Yep, haven't we? So that means in the function of g, which was g of x was x plus 1. Oops. Sometimes it does that. G of x equals x plus 1. So I'm going to replace x with 3. 3 add 1 is 4. Okay. Now I know this bit there is 4. So now my next step is we've done g, f of 4. Now the function of f was x squared, so I'm just going to do 4 squared, which is 16, and that is your answer. Okay, let's have a look at another example like this. This time I'm going to change it a little bit. I'm going to do fg of x. Okay, now slightly tricky this time. I've got no numbers. So this is a higher level question where you are asked to use your algebra skills, okay, when answering questions like this. Now, it says g of x. Now, I know that g of x was x plus 1. Well, it doesn't give me a number, so I can't substitute anything into this function. There's no number, there's nothing. It just says that I've got to keep x as x. Okay, so I know that this here is x plus 1. So I'm going to write f of x plus 1. That means that in the function of f, I've got to replace x with x plus 1. Now, if I write down here, the function of f was x squared. Now, remember, I've got to replace x with x plus 1. So it's going to be x plus 1 squared, and that is your answer. Okay, so yes, it's slightly more complicated, okay? And it does get very, very, very complicated. Let's have a look at a few more examples like this because these are very complicated. So number 2, let's change it a bit. Let's say f of x equals 4x minus 2. G of x equals x squared. Let's say h of x. We're going to have quite a few functions here to choose from. We might not use all of them. H of x equals x over 2 plus 1. And then we've got I of x, which equals x plus, oops, let's get rid of that bracket mistake, equals x plus 2 all squared. Okay. Right, let's have a look at the first example then. Let's do hf of x. So we've got to start off with the f function of f, which is 4x minus 2. Now remember, we don't know what x is. There's no number here, so we're doing algebra examples. So these are quite high level questions, quite complicated. So I know this bit here is 4x minus 2. So I'm just going to bring h down. So it says h of 4x minus 2. That means in the function of h, I've got to replace x with 4x minus 2. We'll have a look at the function of h. H is x over 2 plus 1. So that's going to become, I'm going to just get rid of that. Don't need it. Complicates things. Instead of x, I'm going to write 4x minus 2 all over 2 plus 1. Okay. And there we are. I'm going to leave it at that for now. I know that you can simplify this and change it about. So let's do that actually, because we can. It looks a bit silly like this, doesn't it? I know that I can half these two numbers. That's going to become 2x minus 1 plus 1. Well, minus 1 plus 1 is nothing, so it's just 2x. Okay. And that is your answer. So where you can simplify it. Okay. Let's have a look at another example then. Let's change the colour of my pen. Let's have a look at B. So this time I'm going to say, let's have a look at g f of x. Okay, so we're going to take the f function first, which is 4x minus 2 again. And I need to apply g to it. Now g says I need to replace, well, g is x squared, isn't it? So I've got to replace x with 4x minus 2. So I've got 4x minus 2 all squared, and I can leave it as that. I don't have to multiply the brackets out. Okay. Right, let's have a look at another example. Right, another example. Let's have a look at I f of x, and then we change it about a little bit. So again, we've got the function of f, which was above 4x minus 2, and I've got to apply I to it. Okay, now if I look back at the top, I was x plus 2 all squared. So whatever x is, I'm just going to write that down here so you know. The function of I is x plus 2 all squared. Okay, so where I've got x, I've got to add 2 to it, and then I've got to square it. So I've got, well, x is going to be 4x minus 2. I've got to add 2 to it, and then I've got to square it. Well, let's sort this bit out. Minus 2 add 2 is nothing. So I've just got 4x all squared. And I can simplify that actually, because 4 squared is 16. So that becomes 16x squared. Okay. So you can see that these are quite hard to do. There's a lot of thinking involved, a lot of algebra involved in these questions. Let's have a look at something else. This time, let's do g of x. Oops. Okay. Well, let's remind ourselves what the function of g was. G was just x squared. Okay, so that there is x squared. I've got to apply g to it again. So instead of x, we've got to replace x with x squared. So x squared all squared. Yeah, well, use your knowledge of laws of indices, and you know that I've got to do 2 times 2 there, so it becomes x to the power of 4. Okay, let's have a look at another question, E this time. Let's do something slightly more tricky, h f g of x. Now I'm just going to write down a different color. Let's do it in black actually. I know the function of x was, just change the thickness of my pen. Get rid of that. Okay. F of x was 4x minus 2. Then g of x, we're looking at g. G of x was x squared. And then we need h of x, which was x all over 2, add 1. Okay, so g of x here is x squared. Okay, and then we've dealt with the g, so f, then we look at f first, okay, and then we bring down the h afterwards. So, okay, so f says 4x minus 2. So instead of x, I've got to replace it with x squared now. Okay, so I've got 4, and then I've got x squared minus 2. Okay, that's that bit done. And then I've got to replace that with h. Now, In H, where my x is, I've got to write 4x squared minus 2. So let's do that. 4x squared minus 2 divided by 2, add 1. Let's simplify this. Well, I can half this, can't I? That becomes 2x squared minus 1, add 1. Well, that cancels. I'm just left with 2x squared. Okay. So again, slightly tricky. Let's have a look at another question like this because it is quite difficult. Okay. So this time, what was E? We're on F now. Let's have a look at HFI of x. Okay, let's just write down what we need. H of x was x over 2, add 1. F of x is x, add 2. And then I of x was x plus 2 all squared. Okay, right, let's have a look at this then. So I need I of x. I'm just going to change the pen color. Oh, I of x is actually x plus 2 all squared. And I need to apply f to it. So instead of x plus 2, I need to do x plus 2 all squared plus 2. Okay, and then actually I need to apply h to it now, don't I? So instead of x, I'm going to write x plus 2 all squared plus 2 divided by 2, add 1. Now we need to simplify this. So we need to expand this double bracket. That becomes x squared plus 2x plus 2x plus 4, x squared plus 4x plus 4. Okay, so I've got x squared plus 4x plus 4, add 2, all divided by 2, add 1. Okay, right, so then I've got x squared plus 4x plus 6, divide that by 2, add 1. Well, I've got a bit of a problem because I actually can't half x squared plus 4x plus 6 because they're all together, isn't it? It's all 1. The x squared can't be halved because it's 1 and I'm going to be left with a decimal. So what I'm going to do is I'm going to put this under a common denominator so I can add them both together and see what happens. So this here, I'm going to change that into a common denominator. So I'm going to have x squared plus 4x plus 6 all over 2. Add, well, that at the moment is 1 over 1, so I need to times it by 2, 2 over 2. So that becomes x squared plus 4x plus 6 plus 2 all over 2. So then again, x squared plus 4x plus 8 all over 2. And that is my answer. Okay, so nice and simple and nice and straightforward. Okay, I'm going to leave it as that. Let's have a look at one more before we end our session. So we have got F, G. Let's look at G then. So the ones where you have to substitute 3 in are more complicated, I would say. I'm going to do F, F, G of X. Okay, I know that G of X is x squared. And F of X, is actually x plus 4x. 4x minus 2. Okay, so g of x here is x squared, and I've got to apply the function of f to it. So I'm going to do 4, well, instead of x, I've got to replace it with x squared, so 4x squared minus 2. And then I've got to apply f to it again. Okay, and so instead of x, I've got to put in 4 times 4x squared minus 2 minus 2. And let's just times that out. I've got 16x squared minus 8 minus 2, well, 16x squared minus 10. And that is my answer. Okay, nice and simple and nice and straightforward. It does get quite complicated when you've got lots of algebra things to do. Okay, and again, you know, you might be asked to you know, work out things using algebra or just using numbers. So let's have a look at something else just before we finish. So you might end up with something like this as well. So I'm just going to say f of x equals 3x squared plus 2. I'm going to say that g of x equals x plus 4 all squared, and I'm going to say h of x equals 3x plus 2 all over 6. Okay, so first example I'm going to do, and let's do it in a different colour, fg of 6. Okay, so let's have a look. So I'm going to do in the function of g, I'm going to replace x with 6. So I need to do 6 plus 4 all squared, don't I? 6 plus 4 is 10. 10 squared is 100. Then I need to apply the function of f to that. So instead of x, I'm going to do 3 times 100 squared plus 2. Well, remember big maths, you've got to do 100 squared first. So 100 times 100 is, well, 10,000. Times that by 3, okay? And then add 2 to that. Nice and easy. Okay. Right. Let's have a look at another example. Something that gets slightly tricky then. We've done this before right at the start. I just thought I'll show you a few of the questions that can get quite tricky. Let's do a very tricky one before we leave. Let's do G, H, F, G of minus 4. Okay, so let's do G of minus 4 first. So that means I've got to do minus 4, add 4, all squared. Well, minus 4 add 4 is 0. 0 squared is 0. I've got to apply f to that. So where I've got 0 in the f function, I've got to substitute that with 0. So that's 3x squared add 2, isn't it? So I've got to do 3 times 0 squared add 2. Well, 0 squared 0, so 3 times 0 add 2. Well, 0 add 2 is just 2. Right, so we've done the G, we've done the F, now we've got to apply H to it. So it's H of 2 now. Well, H was, if you're looking back, 3x, to zoom out a little bit so you can see. Okay, so I've got to replace the x with 2. So 3 times 2 add 2 all over 6. Well, 3 times 2 is 6. 6 add 2 is 8, so 8 divided by 6, I'm left with a fraction. You can simplify that if you want, you can leave it as it is. I'll just leave it as it is for now. So I've applied H, I've now got to apply G to that. Now G was, x plus 4 all squared. So I've got to do 8 plus 6 plus 4 all squared. So 8/6. Okay, but if I simplify that, I can half it. I get 4/3 plus 4 all squared. Okay, now I need to add these together, so I'm going to put that in the common denominator. Okay, if that becomes under 3 times top and bottom by 3, that's 12. So 12 add 4. Okay, so 12 add 4 is 16. 16 over 3 all squared. Okay, and that becomes 16 over 3 times 16 over 3, and then nice and easy, 16 times 16 is 256 over, well, 3 times 3 is 9, and that is my final answer. Okay, so you can be asked some quite tricky questions, things to do with algebra, where you've got to substitute numbers in. This is why it's quite a high level skill to do. I hope this lesson was useful for you. Thank you for watching.